Betelgeuse is a red supergiant star in the constellation Orion, one of the brightest stars in our night sky. It sits roughly 640 light-years from Earth. Ancient civilizations watched this star for thousands of years. The Greeks placed it on Orion's shoulder, and Arab astronomers gave it the name we use today. But Betelgeuse is dying. This massive star is in its final stages, and one day it will explode as a supernova. When it does, it will shine as bright as the full moon, visible even in the daytime for weeks. No one knows when. It could happen tomorrow, or it could take another 100,000 years. Today, we're traveling across the stars to see this dying giant up close. This star is massive, one of the largest stars visible to the naked eye. Civilizations looked up at this bright red light in the constellation Orion. The ancient Greeks saw it as the glowing shoulder of the hunter Orion. Arab astronomers called it the hand of the giant. In Japan, it was called Akaboshi, the red star. None of them knew what it truly was. If this star replaced our sun, its surface would extend far beyond Mars, possibly reaching Jupiter's orbit. Its diameter lies somewhere between 900 and 1,200 times that of the sun. More than 1 billion suns could fit inside its volume. Its outer layers aren't smooth. Giant convection cells, some spanning a significant fraction of Earth's orbit, rise and fall across the surface. These movements distort the star's shape, making it bulge and shift over time. Millions of years ago, this object was a brilliant blue star, somewhere between 15 and 20 times the mass of the sun. Massive stars evolve quickly. After exhausting their hydrogen, their outer layers expand while the core contracts, triggering new rounds of fusion. First helium, then carbon, then neon, then oxygen, and finally silicon. Each stage burns faster than the one before. Hydrogen fusion lasts millions of years. Silicon fusion lasts only days. The star is unstable now. Its brightness changes noticeably, sometimes nearly doubling, other times fading significantly. Historical records show that ancient astronomers observed these variations as well. In late 2019, an unusual event occurred. Over a few months, the star dimmed by nearly 40%, becoming the faintest it had been in more than a century. Astronomers wondered whether this was the early sign of a supernova. Instead, the fading was caused by a massive cloud of gas ejected from the surface. As it cooled, it condensed into dust thick enough to block a portion of the starlight. Telescopes captured images showing a large, dark patch on one side. Within months, the dust dispersed, and the brightness returned to normal. The event confirmed that this red supergiant is losing mass, shedding its outer layers as it approaches the end of its life. Deep inside, fusion continues through heavier and heavier elements. Eventually, the core will begin producing iron, and that is the point where everything changes. Iron fusion absorbs energy instead of releasing it. Without outward pressure, gravity takes over. The core collapses in less than a second. The rebound sends a shockwave through the outer layers, tearing the star apart in a Type II supernova, one of the most powerful explosions in the universe. For a few weeks, the blast will shine brighter than the full moon, visible even during the daytime. At night, it may be bright enough to cast shadows. The explosion will release more energy than the sun will produce over its entire 10 billion-year lifetime. What remains depends on the final mass of the collapsed core. If it's below roughly 3 solar masses, the result is a neutron star, an object so dense that a teaspoon of its material would weigh as much as a mountain. If the core is heavier, it will collapse into a black hole. Astronomers still don't know which outcome this star is heading toward. They also do not know its exact size or precise distance. Current estimates place it somewhere between 530 and 720 light-years away. This red supergiant is one of the few stars large enough that we can image its surface directly. Most stars appear as single points of light, but this one is close enough and wide enough for telescopes to capture visible surface features. The eventual supernova poses no danger to Earth. Explosions of this kind only threaten planets within about 50 light-years, and this star is more than 600 light-years away. The only effect we will experience is light. Because that light takes centuries to reach us, the explosion might have already occurred. We simply haven't seen it yet. Astronomers monitor this star constantly, knowing that when the moment comes, it will be the closest supernova witnessed in modern history. The last one visible to the naked eye was in 1604, more than 400 years ago. When it finally collapses, neutrino detectors on Earth will detect the event minutes before any visible light arrives, giving scientists a brief but valuable warning. We're getting closer now. From this distance, the star doesn't look like a perfect sphere. Its surface is uneven and constantly shifting, shaped by powerful convection rising from deep inside. Bright regions and darker patches drift across the photosphere, some of them many times larger than Earth, giving the star a mottled, restless appearance. There's no solid surface here. The gas simply becomes thinner and thinner until it fades into space. Material escaping from the outer layers forms a hazy envelope around the star, and some of that gas cools into dust, creating a faint glow that extends far beyond the visible edge. The light here is a deep orange-red, far richer than our sun's yellow-white glow. Everything is washed in that color. This giant is also moving rapidly through space. As it travels, it pushes through the thin interstellar gas ahead of it, creating a curved bow shock almost a third of a light-year across. Astronomers have long suspected that a small companion star may orbit close by, but its presence is difficult to confirm from Earth. If such a companion exists, it could help explain the star's unusual rotation and uneven mass loss. Up close, it would appear as a small point of light drifting through the extended gas around the supergiant. When the core finally collapses, the explosion will tear the star apart and leave behind either a neutron star or a black hole. The expanding cloud of gas and heavy elements will stretch for light years, enriching the Orion region with the materials needed to form future stars and planets. For now, the star continues burning through the last stages of its life, massive, unstable, and approaching its final transformation.